Data analytics is the foundation of AI. Without understanding data, you can't understand or trust the intelligence built on it. This video course is introductory to data analytics for the age of AI. Created by Dr. K. Seefeld. The material used in these videos is in the Text Data Rookie's Introduction to Data Analytics. Available as a free PDF from the website www.dataanalyticscurriculum.com. Chapter 5 Section 2 Data Mining Algorithms. Welcome to this lesson on data mining algorithms. By the end of this section, you will be able to understand the difference between supervised and unsupervised learning, describe classification and regression algorithms, explain how classification algorithms work, understand basic regression types, know the key clustering methods, identify when to use each algorithm. Data mining algorithms overview. Data mining algorithms are used to extract meaningful patterns from large datasets. They are essential tools for tasks like classification, prediction, and clustering. Broadly, data mining algorithms fall into two main categories: supervised learning, which includes classification and regression; unsupervised learning, which focuses on clustering. Supervised learning, classification and regression. Supervised learning uses labeled data, where the outcomes are known. Algorithms learn from these examples to predict or classify new data. Classification algorithms. Classification algorithms aim to categorize data into predefined classes. The output is a discrete label, such as spam versus not spam. Common classification algorithms include decision trees, random forests, and support vector machines, or SVMs. Decision trees. These split the data recursively based on feature values. Tree nodes represent decision rules, and leaves represent class labels. Decision trees are easy to interpret but can overfit small datasets. Random forests. A random forest is an ensemble of multiple decision trees trained on different subsets of data. Predictions are combined via majority voting, which reduces overfitting and improves accuracy. Random forests are robust for complex, real-world data. Example of how random forests work. Each tree in the forest focuses on different features or subsets of data. Each tree votes on the prediction, and the final output is determined by the majority vote across all trees. Support vector machines, SVM. SVM finds the hyperplane that best separates classes by maximizing the margin between them. SVMs are effective in high-dimensional spaces and can use kernel functions, like the radial basis function, to handle nonlinear data. They are robust for both simple and complex classification tasks. Regression algorithms. Regression algorithms are used to predict continuous numeric values based on input features. For example, predicting house prices from size, location, or number of bedrooms. Linear regression assumes a linear relationship between inputs and output, fitting a best fit line to the data. It is simple, interpretable, and widely used. Ridge and lasso regression add penalties to prevent overfitting. Ridge shrinks coefficients, while lasso can reduce some to zero, helping with feature selection. These methods are useful for datasets with many features. Polynomial regression extends linear regression with polynomial terms, capturing nonlinear relationships by fitting curves. Logistic regression is used for classification, predicting the probability of an event occurring. Outputs range between 0 and 1, making it common for binary outcomes, like whether a customer will purchase a product. Clustering techniques, unsupervised learning. Clustering algorithms group similar data points based on characteristics, without using labeled data. They are useful for discovering hidden patterns or structures in datasets. K-means clustering partitions data into a predefined number of clusters, assigning points based on distance to cluster centers and iteratively recalculating the centers. K-means is efficient for large datasets but requires specifying the number of clusters in advance. Hierarchical clustering builds a dendrogram showing nested cluster relationships. It can be agglomerative, which is bottom-up, or divisive, which is top-down. Hierarchical clustering does not require specifying the number of clusters beforehand but is computationally expensive for large datasets. DBSCAN clustering is a density-based method that identifies dense regions as clusters. It does not require specifying the number of clusters and handles noise and outliers well. DBSCAN is suitable for clusters of arbitrary shapes and varying densities. Data mining algorithms are tools that help uncover meaningful patterns and insights from large datasets. They enable organizations to classify, predict, and group data, supporting smarter decisions and revealing hidden relationships.